Okay, welcome. As you can see, we are about to build in Microsoft Excel uh, an application that's going to solve 3x3 systems of equations for us going into Gauss-Jordan elimination. So I'm working under the assumption you have some background in Gauss-Jordan elimination. So let's go ahead and get started with this. Let's say we are going to set up a little space. And I've got this set on a big setting right now. It's not important that you do that, but this is just for the video. Let's go ahead and say we're going to put in our x coefficients, our y's, our z's, and these will be our results in here. We'll put in from our equation. So this is three equations, three unknowns, and we're just going to enter the coefficients. That's going to fit into this matrix area. So I may want to do something here like put some borders on the left and put borders on the right. Not totally important that you do that. You can make those thick, but this is just going to give a space where the user can input information. So I'm going to go ahead and just enter, let's go ahead and enter this value, or these equations. 2x plus 3y minus 4z equals 2. And let's go 3x minus 2y plus 6z equals 3. And let's go 5x minus 3y minus 2z equals 7. Okay, just kind of randomness there, but that's going to be a space where the user can come in and put in entries, and then we're going to go through the work so that when they enter those, they will immediately be able to view the answer. In fact, I might put over here x equals, y equals, z equals, and give them space to actually put the solutions over here. For mine in column H, the location of these is really not that critical. Okay, so the process we might go through on this, I'm going to put some just scratch work over in here. As this course was taught, I'm going to use this 2. This is what I refer to as our hired hitman. I'm going to use this 2 to wipe out the 3 and the 5 over here. And 2 and 3, I could divide this first row by 1, but then we have to deal with fractions. I'm not going to do that. I'm going to go ahead and find where 2 and 3 match up. And 2 and 3 match up, the least common multiple of those is 6. It's not important I get the least common multiple. It is important I get a common multiple. In other words, if this value was 4, and I was doing this by hand, I would have these match up at 4 by multiplying the first row by 2. But that's a decision that I'm making kind of on a human level. Excel doesn't mind if we just have these match up at 2 times 4 or 8. So I'm going to go ahead and multiply. This is in effect what I'm going to be doing. You don't really have to show the work I'm doing over here. This is just to help you understand the process. I'm going to multiply the first row by 3. I'm going to multiply the second row by 2. And then I'm going to subtract those rows to get a new row 2. Let me show you what I'm talking about here. So first thing I'm going to do is where I start my second step matrix, I'm going to go ahead and just set this cell, type in equals, and I'm going to click to get that B3. I placed my first item in B3 and I hit enter there. So if I change this 2 to 7, it gets changed automatically. So important to realize I did not enter in B7, I did not enter the value 2, I entered equal to B3. And I can continue that for all of that row, or I can replicate this across into those values. So if I look over here at -4, oh, yep, it's equal to this guy up here. Okay, now the next 2 rows of values are going to change. Again, my hitman 2 is going to take over and wipe out this 3 and wipe out this 5. These values should change accordingly. So here's the process. I'm going to, in this, where the 3 was, I'm going to put equals what it was times, that's shift 8, times my hitman, and this is going to be kind of weird for this first value, minus complete the rectangle of array. Now, you got to stick with me on this. This will make more sense as I move across this second row. So complete the rectangle times this minus this, which is kind of a weird equation because, of course, Let's do this again. B4 times B3 minus B3 times B4, and I get 0. It's always going to be 0 here. Take a look at this equation. Kind of weird that we would do that, but you're going to get the gist of why it is we're going about that in just a moment here. All right, so let me go ahead and resize this guy down to something. Let's jump into this equation right now, and I think you'll follow what I'm doing. Equals the value that used to be in this spot in the matrix right here. I'm clicking on it. Times the hired hitman minus complete the rectangle. So this guy times this guy. So in effect, what I'm doing, see my C4 value here in blue? I'm multiplying it by 2, which is what I would be doing to this row. I'm subtracting from that my 3 that I'm multiplying times this 3, what I'd be multiplying this row by. But we're going to just keep doing this over and over. You will definitely catch on to this. Okay, so you'll see we can speed up on this. So this cell is going to equal what it used to be, that value of 6 times the hired hitman, minus complete the rectangle multiplication. This guy times this guy. Enter. Equals what it used to be. I'm clicking that in. I'm not typing in E4. I'm clicking on that cell. If I clicked over here, I'd get F6. What it used to be, E4 as it turns out, times hired hitman. And now I complete this rectangular array here. Minus this times that. Complete the rectangle. Pretty slick. That's kind of a bonus or coincidental 0. Okay, now I'm going to let the 2 wipe out the 5. What would I be doing to make that happen? 2 and 5 would match up in 10. I would in effect be multiplying this guy by 5. I would in effect be multiplying this row by that 2. Okay, so I'm going to come right down here to my new value. In B9, I'm going to go, excuse me, equals what it used to be times the hitman. This is the weird one. Minus complete the rectangle. Well, that's just this times that. Of course, that's going to be 0. Equals what it used to be times the hitman minus complete my rectangle. That's going to be my 3 value and my 5 value minus this times this. Enter. Equals what it used to be times hitman. I created a rectangle. I need to get the -4 and 5 in here. Minus the -4, which is really being multiplied by this 5 out here to the right, but that 5 came from, of course, my last entry here, times my last entry, column 1. And finally, this value equals this times my hitman minus complete the rectangle, this times this. Enter. So there is our second matrix. First hitman has done his job. Now, if you were doing this by hand, you might come in and look and see, can I reduce these rows, maybe multiply each of these rows by -1. Excel doesn't care. We're just going to carry on the values that we have. So my new hitman now, I go down the diagonal. I start with this guy. My next hitman is this -13 value. I'm going to color it for reference. And I'm going to start my new matrix right down here. I like skipping a row, kind of give me a little bit of separation there. What's not going to change in this step is this row is going to be repeated exactly as it is. So I'm going to come down here and I'm going to go equals what it used to be, and that's it. I'm going to replicate that across, and I pick up my -13, my 24, and my other 0. Okay, this value, here's our process, equals what it used to be, its relative location. This times the hitman, I created a rectangle, minus complete the rectangle, this times this. Here's the weird one, equals what it used to be times the hitman minus complete that rectangle. Well, I repeat these values, this times that. equals what it used to be times hitman minus complete the rectangle. See that? Very visual. Very visual. Equals what it used to be. Whoops. What it used to be is up here. Times our hitman minus complete the rectangle. Okay, row 3. I can even do that with the 0. In theory, I could just put 0 down here, but I'm going to go ahead and go through the process here. This will help us if we create any errors. Equals what it used to be times our hitman minus, whoops, I never clicked it in, minus this times that. Complete the rectangle. You might have caught me there. Equals what it used to be times our hitman. See, that's the reason it's so nice to have that hitman colored. It takes us right to our spot. Minus complete the rectangle. Weird rectangle. This times this. Equals what it used to be. Hitman minus complete the rectangle. And equals what it used to be was right here. Times our hitman right here. Minus complete the rectangle. You just say it over and over. You're going to hear me say it over and over for another step here. Just keep saying it over and over as you're going through the process. What it used to be times the hitman minus complete the rectangle. Okay, next step. New hitman. I use this position as hitman. I've used this position as hitman. I will now use this position as hitman, so I'm going to color it. In this space, my next matrix, this third row is going to stay the same. So hitman row stays the same, equals this, and replicate. So let's start with this negative 26 value. It goes in this position, equals what it used to be times the hitman minus complete rectangle. And it gets big. And like I said, if we were going through this by hand, in this up here, we'd do some house cleaning here. We would reduce this all by 2. We could probably reduce this certainly by 2, maybe by something more than that. Can't reduce that one unless you want to go to fractions. Okay, continue. Equals this times this minus complete the rectangle, this times this. That better be 0. And it is. We should never lose a 0 we worked for. Equals this times this weird rectangle minus this times this. And equals what it used to be right here times the hitman minus complete the rectangle. And row 2 equals what it used to be times our hitman minus complete the rectangle with multiplication. Equals what it used to be times our hitman minus complete the rectangle. Equals what it used to be times the hitman, the strange one, minus complete the rectangle. And finally, equals what it used to be times the hitman minus complete the rectangle. Enter. Okay. So we now know that 296 times z is negative 52. We now know that negative 3,848y is 1,248, and negative 7,696x is negative 8,736. One more. We're going to go ahead and just clean this up by this value needs to become 1, 0, 0, 0, 1, 0, 0, 0, 1. I, in effect, am dividing this row. I'm going to divide this row by this value. So equals, this is weird, but it's going to be 1, this divided by this. Enter. Equals this divided by that. I know that's going to be 0, and you could technically put down 0, but if we enter a 3x3 system with inconsistent solutions, we're going to want to have those equations in there. They'll speak to us a little bit. Equals what it used to be. We're dividing this row by that value. And here's the biggie. Equals what it used to be divided by this value. Enter. And we'll come back to that, and we'll take a look at that maybe as a, that decimal might go on. We'll see if we can get that into a fraction form. Not sure. Okay, this row, we're dividing this row, row 2, by negative 3848, or in my case, cell C16. So equals what it used to be, 0, divided by this. I know that's going to be 0. Equals this divided by this. I know that's going to be 1. Equals this divided by that. And here's the important one. Equals this divided by that. Okay. And finally, the last row I need to divide by 296, or this cell more importantly. So equals what it was divided by 296, or D17, better yet. Equals what it was divided by that guy. Equals what it was divided by itself. Seems weird, but sometimes that value might be a 0, so we're going to want the formula in there, not just to put 0 here. Otherwise, we'll get some false information. Or not to put 1 here, excuse me. And equals this divided by that. Okay? Now, I've got those values in E19, E20, E21. I'm going to go ahead and call those values right up in here. So I'm going to go equals, looks like I need to get my font a little bit bigger here. Let's go ahead and font this all out a little bit bigger here. Let's go 36. So I'm going to go equals, and I'm going to call that cell that's containing my x value in it right here. Enter. So we're just transposing that up here so the viewer can just see it right next to it. Likewise, y equals my y value. And some of you may notice we could just be replicating those. Z equals the value that's in cell E21. Okay, I'm going to go ahead and select those values. I'm not sure if this is going to work or not. I don't know what kind of fractions I'm going to have here, but I'm going to go ahead and select those. I'm going to right-click. I'm going to format cells, hopefully. I'm going to go to number. I'm going to go to fraction. And I'm going to allow up to 3 digits. And I'm going to click OK. I get that number sign only because I didn't have enough room to put this in. And there we have it. So I don't need this. There is a Gauss-Jordan problem. And you might say, well, that's a lot of work to solve a system of 3x3 equations. And my point would be we didn't just solve a system of equations. We solved all the systems of all the 3x3 systems of equations. For instance, if I change this 5 to 4 and I hit enter, watch my values over here, x, y, z. I'm going to hit enter in 3, 2, 1, go. There's my new values. What if I change this value from 3 to 37 in 3, 2, 1, enter. Okay. So this is all of our 3x3 systems. Now what happens in the event, let's say we have a similar system here. So in other words, let's say this guy is 4, -3, -2, 3. Well, we can't have an equation where 4x minus 3y minus 2z is 3, and also 4x minus 3y minus 2z is 7. So we get this error along the way, and we see that would start to occur. We'd see a problem right here. Or what if we had two equations that ultimately were the same, or linear combinations of one another? That's recognizable on our way here. That's why I want to use the formulas even when it seems like we should just put zeros and put ones in place. Okay, so anyway, there you have it. There's some pretty cool things we can do along the line of like hiding some values, hiding some rows that we might not be interested in seeing. But pretty slick little program there, where much easier to use now than our calculator, and just kind of fits into the whole life philosophy of if we're going to be doing something, some process oriented mathematics, and we're going to be doing that repeatedly, maybe we want to build a machine to do that for us. So hope that was of some interest to you. There are some things that we could do to add. Like I said, we could hide and show some rows. So maybe we don't want to see the scratch work. Maybe all we want to see is the final answer here. That's something we can talk about in the lab, or you can experiment around with. Maybe we'll add a button to this, but a really nice, useful process here. Clearly, you could do the same process and set up a 4x4 system, a 5x5 system. But by the time you get into bigger systems, Excel offers a really nice alternative to going through this Gauss-Jordan process, and that'll be approached with Cramer's rule, which we'll talk about in the future. So thanks for viewing. I hope that's helpful, and bring that knowledge into the lab with you. What's the most important thing to remember? When we enter a value, when we enter an equation, we're going to, let me go through one more time with this. We're going to say this cell equals what it used to be times the hitman minus, here's our completed rectangle, this times this. So if you followed along with that, go ahead and try to create one. We'll be doing that in the lab, maybe have time for a 4x4 system as well. Once again, thanks for viewing, and stay tuned.